again. We got another problem here with geometric sequences, but the way we approach this is going to be a little different. Let me just put up a sequence just so we have something to talk about before we get into the problem. One way that you can think about a geometric sequence is that if you're on any step of it, you can multiply by a certain number to advance by one step, and we call that number the common ratio. So here we could say starting from 5, if you multiply by 2, you get to 10. If you multiply by 2 again, you get to 20. And if the sequence continued, you would continue going times 2 is 40, times 2 is 80, times 2 is 160. And you could do that indefinitely and get more and more terms. So one way to think of these is term times common ratio equals next term. But there's another way to think of it, which I think will serve us better for this question. I'll keep the same sequence, but we're just going to see it from a different angle. Another way to take this is for any geometric sequence, any term divided by the previous term will give you r. That'll happen every time if the sequence is geometric. So with this thing, we could say if you do 10 divided by 5, that comes out to 2. We know that's our common ratio. We saw it earlier. Or you could do 20 divided by 10, and oh, there it is again. I said the next term would be 40. If you did 40 divided by its previous term, this number keeps coming up. So any term divided by the term before it should give you the same answer over and over, and that answer is your r. And we can use that to attack this problem, I think. Here they've given us three terms which are a little odd looking. They have pluses and minuses in them, which is not what we're used to seeing with the geometric, but whatever, we'll handle it. These are our three terms. And based on what I just said, if you take one of these terms divided by the previous term, that has to give you r. So we can say x over x plus 3 would come out to r. I don't know what r is yet, but we'll get to that. Also, if I do x minus 5 divided by its previous term, x, that also must come out to r. Okay? Any term divided by the term before it. Now, what clinches this is, if both of these things are equal to r, then they must be equal to each other, and we can say x over x plus 3 must be the same as x minus 5 over x. That's an improvement. Up here we had x and r as variables, and we didn't know either one of them, so we were kind of stuck. Now we have a single equation with just one variable in it. Maybe we can crack this. If we cross multiply this thing, or multiply by x and x plus 3 if you'd rather, we get x times x is x squared equals, and going this way we get, I don't want to foil too fast and screw it up, so let me take an extra step. That's going to turn into x squared equals x squared minus 5x plus 3x is minus 2x minus 15. All right, let me create some space and we'll finish solving that. I thought that was going to be a quadratic, but something lovely happened. The x squareds are going to cancel out, so this actually won't be quadratic in a moment. We can subtract x squared from each side and we get 0 equals negative 2x minus 15. Add 2x to each side. La 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 la. Divide by 2. X must be negative 7.5. Okay, is that an answer? I can't tell at a glance, but if we know what x is, we can plug it in here and here and here, and that'll give us actual numbers, and then we can look at those and decide if they are in a geometric relationship or not. So this first term would be negative 7.5 plus 3. And this next number would be negative 7.5. And this last number would be negative 7.5 minus 5, which is negative 12.5. I can't eyeball that. I'm going to have to check. If we want to know if these are geometric, remember our original thing? We said if you do term divided by previous term, you should get the same number over and over. So to test this, if we do negative 7.5 over negative 4.5, that gets us, on a good day, I could probably do that in my head, but this is Friday, so calculator says 1.6 repeating. And then if we do negative 12.5 divided by negative 7.5, hey, look at that, 1.6 repeating again. So they didn't ask for the common ratio, but if they had, we could tell them the common ratio is 1 2/3. And the three terms are negative 4.5, negative 7.5, and negative 12.5, which form a geometric sequence.